Order, order. Welcome to this, our second session of this morning's opening session on food security. The Science and Technology Select Committee, we're looking at the scale and urgency of the global challenge and the UK role in helping to tackle it. Welcome to you both. Thank you for coming. Imran Afzal, CEO of the National Alternative Protein Innovation Centre, and Dr. Hannah Cooper, Assistant Professor in Agronomy, University of Nottingham. We're looking in this committee, obviously we're the Science, Technology, Innovation Committee, and we're really looking at how the UK can play a bigger role in tackling food security, how we can deploy both our science, but also our leadership in the regulation of science, in the globalisation, the impact, the technology transfer of science. We've just been hearing in our first session some of the challenges globally around the world in getting next generation crops into the hands of African and Asian and South American farmers. So can I start by just, as I did in the first session, reminding us all of the global challenge. Sir John Beddington, the former chief scientist, told us in 2010 that we had to double global food production by 2050 on the same land area using half as much water and energy, or face mass famines, mass migration, hundreds of millions of people on the move. And essentially, in this country, we haven't really responded to that. In fact, agricultural productivity has fallen, our reliance on imports has gone up, and our farmers are increasingly wondering whether they're really viewed as a key industry. The government set out a food security strategy, an industrial strategy that references agri-tech, and a trade and investment strategy. And we're really interested to see how we can harness that. So can I ask you both, first of all, just to say something about the scale of the global agri-science research market and the opportunity as you see it in the UK. Perhaps I can start with Hannah and then come to Imran.
Of course. Thank you very much for today and for the invitation, for joining. So just to start with, so Cristobal and Ashmani were talking about some absolutely fantastic technologies that are being developed and being used. But none of this is going to work if our growing medium, soil, is degraded. So my background is soil physics and soil health, so hopefully by the end of today I can convince you that soil is the most important thing. So if we talk just domestically to start with, so the UK has about 17 million hectares of soil in terms of agricultural production. So we've got about 5 million hectares for arable cropping, 12 million hectares in terms of grazing, and about 500,000 hectares in terms of woodland. But some of the challenges that we're facing, so about 2.9 million tonnes of soil are being eroded every year. About 5 million hectares are at risk of erosion.
It's in the UK?
In the UK. So it's a huge domestic challenge as well, one that we're obviously battling to remedy with low-tech sensors and technologies, with kind of high-tech enablers. But then if we look internationally as well, so we're obviously not alone, in sub-Saharan Africa, nutrient depletion affects about 135 million hectares, so what Ashmani was talking about before in terms of the global yield potential. So in sub-Saharan Africa, they're currently producing about 2 tonnes per hectare of maize, but they have the potential to produce 10. So you've got that yield gap of 8 tonnes per hectare. If we look to the States, in some of kind of the areas, you've got they're producing about 12 tonnes per hectare of maize, but their potential is 16. So you've got a yield gap of about 4 tonnes per hectare. And equally, soil erosion there as well is contributing to about 10 to 25% reduction in yields. So yeah, domestically and internationally, kind of the threat to soil health is a really, really big challenge.
Thank you. You'll be pleased to know Martin is keen. We've got quite a few questions on soil health, which we'll pick up with you. Thank you very much. Imran.
Yes, so just so I can introduce myself properly, NAPIC is the National Alternative Protein Innovation Centre. We've been running for about a year now. We are an IKC. I don't know if everyone's familiar with innovation knowledge centres, but we are funded by UKRI. We are housed within academia, so we have 4 universities, which I can tell you a bit more about. But ultimately, the purpose of an IKC is to take the science, translate that, and produce impact, right? On the commercial side of things. So I was sort of coming into this with that hat on. So I just want to state that. International. Sorry, George. What was it? Could you just reframe the question again? To remind me
Well, in that global challenge of doubling global food production, let me ask you, what's the role of alternative proteins? Yeah, is it a silver bullet? And
we're part of alternative, not a silver bullet, but we're certainly, I believe, alternative proteins play an important part in this transition. So we know that in this country we imported 64 billion pounds worth of food, right, in 2024. We know that the demand for meat is expected to grow by 50% in the next 3 years. So that's globally. That will have huge impacts on the planet, and frankly is beyond the planetary boundaries that we currently state. So these are the challenges. And then furthermore, a local statistic that I want to share is that the half of the wheat that we grow in the UK is used to feed livestock. Like half of it. I mean, this is quite, I think, surprising when you first hear this figure. So yes, alternative proteins does have a significant role to play, but we face a number of challenges, and some of the questions that Samantha was asking earlier on, I don't know if we get the opportunity to talk about how we work with academia and commercial, because I think it's a really important question pertaining to alternative proteins.
Thank you very much. So we're going to dive into alternative proteins and then soil and then the commercialisation stuff. Alison's going to take us away.
Thank you. This is my questions are directed to you, Imran, mainly. Dr. Cooper, you don't need to tell me on soil health. I can rant about the impact of coniferous forests on soil mite populations as much as you want. But could you? It's very apt that alternate proteins comes up, because I've been a vegetarian for 45 years, and because of a health issue, I have had to be wrestling with the idea of, do I need to start eating meat again? So very close to my heart, I know. Mm-hmm. So could you tell us what are alternate proteins and why are they a good thing, both for global biosecurity, but for the environmental impact, but also potentially for health?
Yeah, so I mean, there are different definitions of alternative proteins, but if I try and keep this sort of direct, so these are proteins from non-animal sources, ultimately. There are different technologies that play when we talk about alternative proteins. So on the one end, you've got plant-based proteins, which people will be very familiar with, pulses, etc. And then we sort of migrate into products of traditional fermentation. Then we move on into sort of biomass fermentation, which you're familiar with corn and products of that ilk, mycoproteins. Then we're into precision fermentation, and that will produce certain examples of like dairy proteins, caseins, things like this. And then if we keep going down that sort of pathway, we're into cultivated cell products. So that's sort of the kaleidoscope of different proteins that comprise alternative proteins.
Thank you. And could you just stress why this is important in terms of climate change? What the impact of maybe developing? And I remember get that one, that there was a recommendation that we need to look at and legislate for protein diversification and have a protein transition plan because of the benefits that this can happen in terms of our, biosecurity, food security, but also environmental impact. So could you tell me a little bit about why this is a good thing for us to be looking at and focusing on as a really important strategy for future food security and climate change?
Yeah, because, frankly, the planet cannot support the way that we're consuming protein at the moment. So we need to make changes. There are significant barriers to transitioning to alternative proteins, which we can, talk about.
Could you expand on the barriers?
Yeah, so there's a number of barriers. So, what we're seeing is that the price of alternative proteins has been one barrier. The taste has been another challenge. Accessibility, getting them to market, again, another challenge. Within the UK, we know that the startup CEOs that I talk to in the alternative protein space, they complain, frankly, about the access to facilities, pilot plant, scale-up facilities, getting those products to market. are a huge challenge to them, and they remain to be the case. On the regulatory side of things, I think the guys from Tropic who were here earlier were talking about this a fair bit. I would say that kudos to the Food Standards Agency. They have been working in this area. There is a cultivated cell protein sandbox which has been stood up. I think just a few months ago they started work, and the ambition there is where EFSA would take 5 years to approve food. The ambition there is to cut the time in half, 2.5 years instead. So that's another barrier that we need to face into. We have.
Can I just dig into that, because 2.5 years, this is an urgent issue, and I know with the FSA they put these alternative proteins in an unspecified category called novel foods, and I know within any DEFRA, if any innovation gets plonked in this novel category, it can languish. And I do know that also, and I'm aware of my colleague on my right here, that gene-edited microorganisms are not in the precision breeding legislation as such. So, in terms of regulatory barriers and what legislative change you would think would help to speed that process along, can you recommend any?
I think the foods. Well, if we focus on the CCP sandbox, I think regulators, or the agencies I should say more specifically, they need three things. They need more funding, more money needs to go into these endeavours. They need more expertise, and what I mean by that is more people that bring the expertise. And I think bench hours and resource in terms of looking at the dossiers that come into them, so there is no backlog. So I think if these three things were put into the system, I think we would see results ultimately, or we would help shrink I think you're getting at the time it takes from 2.5 years to...
I should add something. I was talking to the Food Standards Agency yesterday about this. The crucial thing is applications. They're lacking companies coming forward with bids for things to go through that test bed that we set up. And I think this speaks to, I know we're going to get into this later, on public consumer confidence, and the retailers need to be confident that there's a market for it. So...
well, there's a market, because I don't want to have to start eating steak
again.
It
sounds like there's a market here.
Right, so, and Dr. Cooper, you may want to come in on this. So, carrying this all the way through, talking about protein transition plan, and we develop all of that, from the environmental impact and the impact on farming, and the provision that how can we bring farmers with us, and how can we support farmers if we sort of say, right, we're having a transition to alternative proteins, we're going to reduce the amount of wheat you produce for food stock, and we're going to move away from beef herds. How can we make sure that we bring farmers with us in this process?
Really good question. So I think Christobel and Ishmani touched on this earlier, but all about co-development, bringing everyone in at the very first stage. I also think maybe strengthening some of the incentives, so outcome-based payments and things like that, and just kind of transparency and open communication from the get-go. Co-development, if we were to implement new policies and mechanisms, what would it look like? What would be useful to you on the ground at that moment?
And I suggest that in order to do that, we need some data, don't we? Because if we were to reward farmers and pay them more for reducing greenhouse gas emissions, you would very quickly conclude as a farmer, I really want to get away from feeding my cattle wheat grown here. Or, if we had some data, we could start to really reward that, those outcomes. Where are we on the journey to having proper data to capture greenhouse gas emissions of the entire food supply chain?
Yeah, across the entire food supply chain, it's quite tricky in terms of the monitoring and the verification of this, but AI is playing a huge role in kind of speeding this up. There is large data sets already available, so some of the work that I've carried out has shown changing from kind of conventional tillage to the reduced disturbance side of things, so zero tillage, can reduce your greenhouse gas emissions by about 60% over 15 years, and at the same time increase the soil carbon as well. So an AHDB as well are carrying out lots of work in greenhouse gas inventories, but it's all about the monitoring, the measuring, and the verification is the key point as well. Yeah.
And can I just be clear on synthetic proteins? We're talking both effectively meat, replacement of meat, and replacement of plant products. It's both, is it?
Yes.
Yeah. And would you say, where are we in the UK? Are we strong in both? Are we stronger in synthetic meat? Are we stronger in synthetic plant proteins?
I think nearer in, the reality is we've done more work, or the barriers, I won't underplay them. They are there for plant-based proteins, but you could say in terms of TRL levels, we're higher up when it comes to plant-based proteins, and I think when we're talking about fermentation technologies, precision fermentation, cultivated, those are far, lower in TRL, so that they'll take longer to develop.
I met a company in Norfolk recently making gluten-free snacks from pea flour. Brilliant. Peas grown in Norfolk. But to your point, the equipment, they had to ship it to Ireland, and they had to import German machinery. That supply chain piece of putting the flour in and processing it, we were hopeless at it. So it spoke to exactly.
Just add to that point. So I was reading this report recently about pulses. So a lot of pulses grown in the UK are fed to animals, right? Pigs in particular. And it's been identified that in the UK we don't have the infrastructure to fractionate pulses. So we can dry them, we can dehull them, and we can produce low value feed for pigs. But if we had the infrastructure to fractionate, and what I mean by that is to break apart the pulse so that we can extract the protein and the fibre, we would massively increase the value of that pulse. And that point that you just raised there, George, is a classic. We haven't got the stuff to do the transformation. Yeah. And it's not rocket science. It's where government needs to come in and invest, because the private sector probably won't. A farmer's not going to change, to growing more pulses unless they know they can get more value.
We've segued beautifully into soil because, of course, those legumes are capturing, they're doing soil good as well. But I think Samantha wanted a quick point on